Hey guys, I'm Pat Kelly. Okay, in this problem, they ask us to find the sum of the finite geometric sequence that they give us here. Okay, and we like problems like this as students because there's a formula for it. So I've got my formula already written down. Definitely a good first step for this type of problem. And what you can see from your formula then are some of the pieces of the puzzle that you're going to need to plug in. So I need an a sub 1 and I need an r. I guess I even need an n. So let's get started with some of those pieces by realizing, like, to start a1. We need an a1, which is always the first term of the sequence, right? So you can usually do this in your head where you're just plugging in that lower value for the index, 0. So that exponential expression is going to go to 1, being raised to 0 power, and then multiplied by that coefficient of 3. So my a sub 1 equals 3. My r that I also need in that formula, and since this is a geometric sequence, that r is that common ratio. You can always see that in your sigma notation with whatever the base is of that exponential chunk. Is that base is what you're multiplying by each time you're looking for the next term. So my r is 3/2. Okay, this is looking good. Now, I'd like to go to the formula and start plugging in, but I'm missing one piece, and I worry about this. I mean, I care about you guys so much. I worry about you. I don't want you to make this mistake. Be careful. This n, the last piece of the puzzle that I need, what I need you to be careful with is that that n stands for the number of terms in your sum, not necessarily that upper value there for the index. See that 20? A lot of people are going to grab that 20 and put it in for n. That's wrong in this case. N is the number of terms that you're adding up. And if I'm starting at 0 and going up to 20, that's actually 21 terms. So what we're looking for here is s sub 21. And that'll come into play in our computation right there with the exponent. Okay, I want to make sure I put a 21 there. All right, let's put the rest of our pieces in place here. My a sub 1 was 3. I'm going to multiply by, I'm going to set up a big set of square braces for my organization because inside I think I'll use parentheses for my r, which is 3/2. Let's put parentheses around that. And as I tried to warn you about, we will raise that to the 21 power. Someone in your class will make the mistake of raising that to the 20th power. Don't let that be you. Down in the denominator, 1 minus that same r value of 3/2. And I tell you, once these exponents get big like that, like a 21 power, I'm going to grab a calculator. I'm sure you won't mind. Let's grab a calculator for this and put that whole thing in. 3 times, watch your grouping if you're doing this with a calculator that has parentheses. I'm going to group my numerator of 1 minus 3/2 raised to the 21 power, close, divide by 1 minus 3/2 power, close the denominator, and then close the whole thing, multiply to the 3 coefficient. Enter. All right. I am getting approximately, even my calculator didn't want to give me a fraction here, 29921.31. Okay. I wouldn't have done that in my head. So, all right. For these problems, very much the formula, but I gave you my warning. Be careful of that n. Number of terms, not necessarily that top value. Okay? Go try some on your own.